Dr. Taft here again with measures of variability, the next step in our unit on descriptive statistics. So there are a lot of words that are used both in typical English language jargon and also statistical jargon for describing variability. You might hear people talk about use variability itself, or spread, or dispersion. So it's basically whether things with low variability are all kind of clumped up around their central tendency, and things with high variability are spread out far away from their central tendency. So we're going to talk about 4 different types. The first one we're going to talk about is the range. So this is a measure that just takes the maximum value in your variable and subtracts the minimum value of the variable from that. So it describes, it's comprehensive, literally. Those are the 2 values that comprehend the whole of your data set. But the disadvantage is that it's totally defined by outliers. So you could have a whole bunch of stuff crammed in the middle and then 2 weird ones way outside, and then it would look like it had a huge range just as much as if something was like all spread out evenly across them. So sometimes it's not considered as informative because of that. I am not going to try and play a video inside a YouTube video because that's sort of weird and meta, but the variance is the next measure of variability that we talk about. And it has a nice real-world definition, which is it's the average of the squared distances of each object in your data set from the mean. And so if you are spinning around a circle and you stick your arms out, you spin around slower. If you pull them in, you spin around faster. And the variance of the distribution of your body mass is actually what is changing there and affecting your spin rate. So that is the physical analog of variance. To calculate the variance, you take the mean and you subtract it from each individual observation and then square it. You add those all up, and that means that the units are not the same as the original variables or the means, which limits the interpolation variance. And then you divide by the sample size minus 1. This gives you the sample variance. This capital S is the sum sign. So we're summing from the first to the sample size, and that's the sample size minus 1. So standard deviation is the square root of the variance, and that's the average distance of each value from the variable's mean. It has the same units as the mean of the variable itself. So in my mind, oftentimes the standard deviation and the variance are kind of the same, just scaled differently. The standard deviation is the square root of the variance, and so it has the same units as the mean, and that lets you compare the mean and the standard deviation directly, which you can't do with the mean and the variance. So the standard deviation is usually the best measure of variability for continuous variables, just like because it is itself an average, it's an average distance. It works nicely with continuous variables, but it has all the same disadvantages that the mean does. It's very sensitive to outliers, so you have to be a little careful with it. Now, the next thing we're going to talk about involves quantiles, so let me explain what a quantile is. A quantile is a description of where an observation is in the order of the different values that the variable takes. So if you have a low quantile, you're close to the smallest value in the variable. If you have a high quantile, you're close to the highest value in the variable. And there is a reference number for the quantile, so that the nth quantile is the biggest and the 0th quantile is the smallest. And if we use 100 as the reference quantity, then the 100th percentile is the biggest and the 0th percentile is the smallest, and so we use the word percentile instead of quantile. And if we talk about 4 things, so the lowest value, the value that's bigger than 1/4 of the data, then the next value is bigger than half the data, then the next quartile is bigger than 3/4 of the data, and the final one is bigger than all of them. By dividing up the data like that, we call it quartiles. And so quartiles are what are involved in our last measure of dispersion, and that is the interquartile range. So here's the quantiles that we often deal with. So the 5th percentile, the 25th percentile, which is on the first quartile, the 50th percentile, also the second quartile, also called the median, the 75th percentile, which is the third quartile, and the 95th percentile. Well, so the difference between that 75th percentile, also known as the third quartile, and the 25th percentile, also known as the first quartile, is the interquartile range. And that is usually blank, apparently. But when I say, but it's usually the best for ordered discrete variables. So if you're like first place, second place, third place, fourth place, fifth place, and you don't really have a second and a half place, you can still talk about the interquartile range of placing. And so that makes sense. And finally, there is no good measure of dispersion for nominal variables that can't be put in any kind of order, although sometimes what people do is they just count how many different values there are. So is it just heads or tails, and there's 2, or is it like chocolate, vanilla, strawberry, there's 3, or is it like Baskin Robbins, or there's 31 flavors. Sometimes people talk about that as a measure of how variable how dispersed a nominal variable is. So that's it for measures of variability.